And welcome, ladies and gents. It's Mr. Callen coming at you with the lesson for today, Chapter 1, Lesson 8. Goal is to find square roots and cube roots. Homework is listed here. First, I'm going to walk you through the lesson. If you're with Mr. Callen's class, you can go ahead and pause the video when you're ready. Take a look at week 7, 8, Y for your math review. Don't worry about the mental math. So go ahead and pause, complete Y, and come back when you're ready to check answers. Now you know me, I'm just not just going to give you answers. So why don't you pay attention to this? There are at least one mistake, if not multiple mistakes on this page. I do that so students don't just cheat. I also do it so you actually learn from the mistakes of others. So when you're ready, pause, check your answers, find something you might disagree with, and be ready. Sorry about that. Be ready to talk to either your classmates or your teacher about it. All right, pause the video, come on back when you're ready. All right. For those of you, again, Mr. Callen's class, don't forget, coming up on Friday, October 8th, you should be at 90, 40, 24. Make sure you're coloring in your page as you go. I hope it's a good quarter for you with all these grades, 10 out of 20, 10 out of 10, 100% grades. Goal for today, finding square roots and cube roots. Now, you're still going to need what you were learning before. Remember that powers are repeated multiplication, right? So now we're going to use that to actually find square roots or cube roots. Really no idea why people don't write that 2 there. Those are what we call second or square roots. Cube roots are when there's a 3 above that funky radical sign. And sooner or later, we're going to be solving equations that might have powers and roots in them. But for today, we're going to focus on finding square and cube roots. Now, this could be as simple as, look, you got a pizza. It's a square pizza. You got 16 slices. How many slices would there be on each side? Now, that might seem obvious to some of you. What about if it's three-dimensional then? What if you got these fancy little cubic ice cream treats? And you know, it's if you got a certain amount and you want 27 cubic centimeters, how long should it be for its length and its width and its height if that's a perfect cube? That, folks, is what we mean by square or second roots and cube or third roots to find out how much would be on each length of the square or the cube. So let's get into things, shall we? Let's start. A square root, my friends, I don't know why people don't put the 2 there. I really wish they would, but you guys will now know anytime you don't see a number above that radical sign, it will mean a square or a second root. All right, so square root literally means what number multiplied by itself will get 16. The most common mistake that students make is divide into 2 parts. 8 times 8 is certainly not 16. Now at this point, many of you already know the answer. 4 times 4 is 16, but wait a second. Is that the answer? No. The root literally means what is that repeated factor? All I'm going to write here is 4. I'm not going to write 4 times 4. I'm not going to write 4 squared. I'm simply going to write 4. And then we'll move on to the next example where we have the square root. I want you to pretend like that negative sign's not there. We have the square root of 64. What number times itself equals 64? Well, guess what? That 8 times 8 we talked about before. But here's the deal, ladies and gents. It doesn't just ask for the square root of 64. It wants us to take the square root and then take the opposite of that. It doesn't mean negative 8 times negative 8. It says, what is the square root of 64? 8. Now, what is the opposite of that number? Negative 8. Moving right along, speaking of funky symbols, there's that plus or minus symbol. I'm going to ask you guys, when you see that on problems today, copy it down. You will need that knowledge for tomorrow, but just copy the symbol down and go on. All right, so, whoa, this is a decimal. Well, why don't you act like the decimal's not there? If the decimal wasn't there, I bet you would find this quickly. But the decimal is there. So it cannot be 6 wholes, as in 6 times another 6. What we can do is start playing with the decimal. Could 6 be in the tens place, or could 6 be in the hundreds place? And so it's basically just a trial by error. It doesn't work for 6 times 6, so we can just take a guess, and if the one we guess doesn't work, we can try it again. It just so happens that both of these have digits of 6 times 6. In this case, we have 1, 2, 3, 4 decimal places. 1, 2, 3, 4. That's too small. Let's try 6 tenths times 6 tenths. 1 and 2, 1 and 2. Ah, there we are. So, in this case, the answer is a positive or a negative 6 tenths. Remember, when you see that decimal, figure out the digit first. In this case, it was 6 by 6. And then just play around with it. Is it 6 times 6? Is it 6 tenths times 6 tenths? Is it 6 hundredths times 6 hundredths? All right. Next up, we have the second or square root of negative 4. So what number times itself equals this? Is kind of strange. 2 times 2, nope, that doesn't work. A positive times a positive is a positive. What about negative 2 times negative 2? No, that doesn't work either, because the opposite of a negative is a positive. That is not equal. Some of you might be interrupting here and saying, Mr. Cowan, what about a negative 2 times a positive 2? Now, that's a true statement, but that's not what a root says. A root says a number times itself, and negative 2 and positive 2 are not the same number. So what is the answer? Ladies and gents, there is no answer. We're going to write, this is not a real number. How about we write not real, huh? You cannot have any number multiplied by itself that will give you a negative quantity. Please notice the difference, little disappearing ink here. Please notice the difference between this problem and this problem. One of them is real, one of them is not. One of them is doable, the other is impossible. Let's wrap up at the bottom, please. We need some number multiplied by itself to give us 25 hundredths. So if you look at it piece by piece, 5 times 5 will give you 25, 10 times 10. So this answer is going to be 5 tenths. Well, that's a good answer. It's not a great answer. I think you all can tell. Whoa, hello. I think you all can tell that 5 tenths can further reduce down to 1/2. Now they're both accurate, but one's better than the other. The other thing that you can always do, ladies and gents, anytime you have a root with a fraction inside, please feel comfortable, please feel free to rewrite it with the radical sign both in the numerator and the denominator. And then all you got to do is look at it piece by piece. Square root of 25 is 5, square root of 100 is 10, and of course, wake up, Mr. Gallen. And of course, 5 tenths reduces. You'll get the same answer, won't you? So we'll talk more about that in a moment. If you wish, pause your video, page 72, do the got it problems, writing your answers off to the side, and come on back when you're ready. Pause the video now and come back. So once again, if you see a radical in a fraction, you can rewrite it. The square root of 9 is 3, the square root of 16 is 4, and that neither divides nor reduces. Final answer of 3/4. If you had to multiply something by itself to get 81, not a big deal. But we're not looking for 81, we're looking for 81 hundredths. So then you have to ask yourself, is it 9 tenths times 9 tenths? Is it 9 hundredths times 9 hundredths? And in this case, the only one that will work is 9 tenths times 9 tenths. So not only will we write the 9 tenths, but we're going to write that funky plus or minus, positive or negative symbol, and learn more about that the next day. Part C, is it real or not real? Hey, what's the square root of 49? 7. What's the opposite of that? Negative. That one exists. On the other hand, there is no number when multiplied by itself, that will give you a negative 100. So for part D, here's where we write, no, there's no answer. This is not a real number. Two choices from here, ladies and gents. Move into your homework or carry on with me for some more examples. Now we're going to get into cube roots. That's like the ice cream problem. We are talking 3 dimensions. So what would be the length, the width, and the height? Naturally, if you have a 3 above that radical symbol, then we should say what factor multiplied repeatedly 3 times. And interestingly enough, this one happens to be 3. See, 3 times 3 is 9. 9 times 3 is 27. And again, don't write 3 cubed. Don't write 3 times 3 times 3. A root says, what is that repeated factor? Cube root of 125. Well, you guys might already know this one. Some of you notice the 5 at the end. 5 times 5 is 25. 25 times another 5 is 125. So the cube root, again, just write 5. Now, usually by the time we get to the bottom problem, people say, got it, Mr. Callan, not real. That's what you just said, not real. It can't be done, not real. And I say, wait a second. Are you sure? Is there really no number when multiplied by itself that could get you a negative 8? And you're saying, well, I know 2 times 2 times 2 is positive 8. Does the negative work? I mean, before it didn't work. Well, check this out. Negative 2 times negative 2. The opposite of going down repeatedly is to go up repeatedly. Now let's do it again. 4 times negative 2. 4 times we go down. Oh. And so in this case, folks, we do have an answer. And that answer is negative 2. If you were to multiply negative 2 by itself 3 times, boom, it works. So please know the difference between a second root and a third root, and know which one is possible and which one is impossible. Onward, if you want to stop, pause the video, go to page 73, HINJ, come on back when you're ready. Now, lest you think this takes way too long, I would encourage you to use some mathematical reasoning here. Look at this number and ask yourself, do you believe the answer is going to be positive or negative? I missed 6. Isn't that great? Ran out of room. Well, Mr. Callan, 729 is an odd answer, so why don't we immediately scrap all the evens? If you multiply evens times evens, you get evens. Meanwhile, 1 times 1, 1, times another 1, 1. Forget that. 3 times 3 times 3, we already did that. That was 27. 5 times 5 times 5, 125. So I guess the question remains, does 7 work? So we come off to the side, 7 times 7 is 49. 49 times 7 is, what is that, 280, 343? Nah, not big enough, but we're getting closer. So if 7 doesn't work, let's try 9. 9 times 9 is 81. 81 times another 9 is, well, look at there. So save yourself some time with your guesswork. Begin immediately by asking yourself, is this number going to be odd or even? Then follow through with some guesses that are close to that. All right, part I, what number times itself times itself? Oh, this is interesting. If it were positive, it'd be 4. Would negative 4 work? Well, negative 4 times negative 4, positive 16. Positive 16 times negative 4, negative 64. Ding, 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 ding. So the answer for part I, the repeated factor, is going to be negative 4. Last but not least, you guys probably figured this one out right quick. And that is going to be 10 times 10 times another 10. Just write the 10. That is the cube root of 1,000. Folks, we're going to move on. The nice part about videos, at this point you can pause, you can rewind, you can rewatch, you can listen again. Or you can continue on where it says my homework. Try to squeeze this in. Sorry I wrote it so big, but I wanted you to be able to see it. My homework, numbers 1 through 6, 10 through 12, and 25 to 32 on page 75. But you know, Mr. Callan, I'm not going to sit here and do your homework. So I'm going to scroll on back. Again, write those numbers in. If you need to pause your video, come on back when you're ready. I'm going to go back a page to page 74. I think if I help you through these problems, they'll help you through every problem that is coming up on the homework. Now, take a look at number 1. We have the opposite of the square root. I don't know why they don't put the 2. Let's put that 2 in there. What number times itself? Let's act like the decimal's not there. Now, that's an odd number, and it just so happens that I know 13 times 13. But here's the deal. There is a decimal there, which means 13 times 13 is way too big. So let's try two other possibilities. Let's try 1 3/10 times itself. Let's try 13 hundredths times itself. Now in this case, both of them have the same digits, but here we have 2 place values, while here we have 4. And since that is way too tiny, our answer, what is the repeated digit? It's going to be 1 3/10. Oh, and what's the opposite of that? Final answer, -1 3/10. For number 2, Mr. Callan said just write that symbol down for now. We'll learn about what the heck that means tomorrow. But remember, please, anytime you have a radical and a fraction inside of it, go ahead and rewrite it. I wish they'd put the 2 there. But at this point, you guys already know. Square root of 49 is 7. Square root of 144 is 12. For a final answer of positive or negative 7/12. And can we get anything? Well, if there were no decimals, it'd be 12. There are decimals. Wait a second. That says -1 44 hundredths. Can you get anything multiplied by itself? The answer is no. So for number 3, we're going to say this is not a real number. Now at this point, you may pause and go to your homework, or you can stick with me and I'll continue on with the rest of the guided practice. Please note, we are not going to do problems 6, 5, or 4 on the guided practice. Let's skip on down to number 7. Number 7 has a cube root. And so we're looking for a number times itself, and it sure looks like this should be an even number. So 2, 4, 6, 8. I don't know about you, but I latched onto that 6. Let's give it a try. Now 6 times 6 is 36. And if we multiply 36 times 6 again, 6 times 6 is 36, carry the 3. 6 times 3 is 18 plus 3. Ding, 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 ding. So we write, and remember, we're only writing 6. We're not writing 6 to the 3rd power. Onward we go to the next problem. Next problem says what number times itself repeatedly gives us, so is this possible? We know 5 times 5 times 5 gives us 125. Does the negative do the trick? The opposite of a negative is a positive. The opposite of a positive is a negative. It works. Boom. One final problem, is there any number times itself that will give us -8 if we multiply that number times itself 3 times? Let's see. So initially I look at 2. Since it's got to be negative, let's try it out. The opposite of -2 would be positive. And the opposite of positive, there it is. That one looks kind of familiar, doesn't it? So, ladies and gents, at this point, I would ask you to be so kind, rate yourself. Where are you? You understand? Feeling pretty good? Or you still have some questions and you might want to pause, rewind the video, do what you got to do. Homework again, page 75, 1 through 6, 10 through 12, 25 to 32. When I return, I'd be happy to share with you some answers. Of course, you can check. Please check the answers to your odd problems. Please do that in the back of the textbook so you know if you're on the right track or not. You could even check with your partners of the evens if you wish. Just make sure you're learning it because your partner's not taking your quiz. Meanwhile, I will mention one more thing. Looks like I closed it up. I did put a number of things over here. If you'd like to go to Khan Academy, you can open those up. You can go straight into the activity, or you can come off to the side and watch some videos or read an article before you practice. You can continue, watch a video before you practice, watch a couple videos before you practice. That's the nice part about Khan Academy. It'll walk you through it nicely. Folks, that's all I have. Take care, do well. Let's grow.